See this row of poles that go back for quite a long time. Okay, anyway, this is the obligatory at the South Pole picture. Okay, so there's, let's get back to IceCube and trying to make a detector. So IceCube at the South Pole. So as I said, the idea is that we want to put these photodetectors down in the ice between 1,400 meters and 2,400 meters. There's 86 strings, and these are what the layout. This is the South Pole that we just saw. This is the skiway. So this is about a 1 kilometer walk, which I did a lot. There are 60 DOMs on each of these strings. This is a DOM. I'll show you a DOM in a minute. That's a DOM there. And this is one of the holes, okay? So here is a diagram of how we drill the holes. So this is going through the packed snow at the top. That device has copper things with hot water going through it. Then we have a drill that's basically just hot water. So this is hot water spewing out of the end, drilling a hole for 2 kilometers, okay? And so the nozzle delivers 200 gallons per minute with high pressure, 90 degrees C. It takes 2 days to drill a hole 2.5 kilometers. Okay, after you drill a hole, this is then a photograph of setting up to drill a hole. So they bring in this thing. You can see they're not really bundled too much, so it's probably only 10 degrees or so below zero. So the hot water is made by heaters. So there are heaters, and then there are pumps that pump the hot water through these black tubes. Okay, so this is heating up the water, putting it through the tubes. That goes into the tube. This is the drill head, and they're pulling it out. They've drilled a hole. They're pulling out the drill head. Okay. So now they have a hole. Okay, it doesn't freeze. It takes 2 to 3 days for it to freeze because the ice is an insulator. So now we have all these DOMs. We want to put the DOMs into that hole. Okay, and each one of those is a photodetector. There's the photomultiplier. This is the cable with the signals and the support for each of these. This is the spool of the cable. This is, now you can see the hole. There was a DOM that went down into the hole, and so this is what you end up with. If we were able to go under the ice, this is what we would see. All these strings with these photodetectors in them, okay? 86 of them have been placed. And so this is a picture now of one of the DOMs being lowered. This is what it looks like. This is the hole in the ice, okay? This part is just a covering because this is loose snow, so you don't want to fall in the hole. Okay, so this is a close-up view of the DOM, which I'm going to show you in a minute. So on the bottom, there's a photodetector. There's electronics that take the signal from the photodetector and digitizes it, and then sends it through this cable up to the top. Okay, so here we have a DOM. It's heavy, okay? So here is the photodetector, okay? These lines are keeping the Earth's magnetic field from affecting the photodetector. And then on top we have like a computer, okay? There's all kinds of electronics that take all of these signals and digitize them and send them up this cable. this is the cable, okay? Remember there was 60 DOMs on each cable, and so we have to bring up the signals from 60 tubes through this cable, and then I'll show you in a minute where we take it. This is a very rigid cable. It has to hold these things. It only has to hold them for 2 or 3 days because then the ice freezes them. We can never fix anything. That's a bad thing. You can't fix anything in this type of detector, so you got to make it so everything works. So here I am. This was sort of the, I don't know, 10th to last string that was put down. Anyway, oops. This one I got to label as Mickey's DOM, so that's my DOM. While we were putting these DOMs in, outside was a big storm, but we were inside the nice enclosure. I also worked on some detectors that were on the top